Okay, let's get something straight. Almost every developer I talk to uses the term AI agent to describe three completely different things. And look, this isn't just about semantics. Getting this wrong is exactly why your production systems are breaking, why costs are spiraling out of control, and why products are failing. So today, we're going to fix this permanently. So let's kick things off with a quick pop quiz, just to see where we all stand. I'm going to throw three scenarios at you. All you have to do is tell me what's going on in each one. Ready? Scenario 1. Super simple. I open up a chat window, I type in, write a refund policy for my SaaS, and boom, a perfectly formatted policy just appears. One and done. What am I using here? All right, scenario 2. Now imagine a system that's plugged into our company's CRM. I give it a simple command: find this customer's last order. It figures out which API to call, it runs it, grabs the order ID, and just hands it back to me. So what do we call that? And for the grand finale, scenario 3. This time, I'm not giving a command. I'm giving it a high-level goal. Resolve this customer's refund request. This thing then autonomously plans out all the steps. It checks the CRM, it processes the refund in our billing system, it posts the confirmation in Slack, and then it closes the ticket. It handles the whole shebang, end to end. So what is this system? Okay, so if you called all three of those an AI agent, you're definitely not alone. But you're also making a huge architectural mistake. Anthropic, who's been in the trenches with tons of production teams, is super clear that these are three fundamentally different categories. And if you treat them all the same, you end up building systems that are way too complex, way too expensive, and way too fragile for what you actually need. Before we can even really talk about agents, we have to understand the basic building block of everything. Anthropic calls it the augmented LLM. Now, this isn't just a raw language model. Think of it as a base LLM that's been supercharged with three key powers: retrieval, so it can go fetch outside knowledge; tools, so it can interact with APIs; and memory, so it can keep track of what's going on. This is the atom, the fundamental particle that all the other more complex systems are built from. And let's be crystal clear, this is not an agent. Not yet. So if that's our atom, how do we start building molecules? Well, it all falls into three distinct architectural layers. We're going to move from the simplest, most reactive tasks all the way up to the most complex, goal-driven systems. Let's break them down. Layer 1 is just pure generative AI. This was the answer to our first quiz question, by the way. Its whole job is to create content. It's totally reactive and stateless. You give it one prompt, it gives you one piece of content back. It can't act, it can't loop, and it has zero memory from one call to the next. Think ChatGPT answering a one-off question. It's perfect for those discrete, single-shot tasks where a human is going to check every single output. Now we get to layer 2, the actual AI agent. This was our second quiz question. Here we take that augmented LLM we just talked about, and we put it inside a reasoning loop. So the model gets a task, it thinks about what to do, that's the reason. It calls a tool, that's the act. It sees the result, that's the observe. And then it decides if it's done, or if it needs to go again. The absolute key here is scope. It's built to complete one well-defined task, like looking up a customer or fixing one specific GitHub issue. And finally, we're at the top of the pyramid, layer 3, the Agentic AI system. And folks, this is a whole different ballgame. This was our last quiz question. An agentic system doesn't just execute a task, it achieves a goal. And it does that by orchestrating multiple agents, multiple tools, maybe across different systems, and potentially over hours or even days. It plans, it delegates, it handles errors, and it makes sure the job is actually done. It owns an entire business process from start to finish. So let's just lay it all out side by side so you can really see the difference. What's so useful here is how clearly it shows the trade-offs. Generative AI, that's for content creation; single tasks, super low autonomy. AI agents, they execute dynamic tasks with some autonomy, but they're still stuck in a single scope. And agentic AI systems, they automate entire workflows, handle really complex, chained tasks, and they operate with a ton of autonomy. You just can't swap one for the other. Okay, now this next part, this is the secret sauce, the thing that most developers just fly right past. Between that simple GenAI and a full-blown agent, there's this incredibly powerful middle ground that Anthropic calls workflows. These are basically predefined paths in your code that organize how LLMs and tools work together. They're not totally autonomous like agents, but they are way, way more powerful than just a single prompt. Let's run through the 5 key patterns. First up is prompt chaining. You can think of this like an assembly line for AI. It's perfect for tasks that have really clear sequential stages. So one LLM writes an outline, your code checks if it's any good, and then a second LLM writes the full document based on that approved outline. Simple, predictable, and incredibly effective. Next, we have routing. This is basically a smart traffic cop. An initial LLM call just looks at the user's request and classifies it. Is this a sales question, a support ticket? Then it routes that request to a specialized model or a tool that's perfectly tuned for that specific job. This is an absolutely brilliant way to optimize for both performance and cost. Pattern 3 is all about doing things at once, parallelization. It comes in 2 flavors. The first is sectioning, where you break a task into independent parts that can all run at the same time, which is great for speed. The second is voting, where you run this same task multiple times, maybe with slightly different prompts, and then you combine the results to get a much higher confidence answer. Now, orchestrator workers, this is where things get really dynamic. You have a central orchestrator LLM that acts like a project manager. It analyzes a complex request, breaks it down into subtasks on the fly, and then delegates them to specialized worker LLMs. The key here is that the subtasks aren't predefined. They're decided at runtime based on what you ask it. And finally, we have the evaluator optimizer pattern. Think of this as a writer and editor loop. One LLM generates a draft, and a second evaluator LLM critiques it based on a list of criteria you give it. That feedback goes back to the first LLM, which tries again. This loop just keeps going until the output hits the quality bar you've set. And this brings us to what might be the single most important takeaway from this entire explainer. Here it is. Most of the problems you're actually trying to solve in a real production environment don't need some complex, unpredictable, fully autonomous agent. They can be solved more reliably, more cheaply, and more safely using one of these 5 workflow patterns. Over-engineering is the real enemy here. So we have the theory, we've got the layers, we've got the patterns in our back pocket. Now for the really hard part. How do you, as the architect, actually decide what to build? This is it. This is the question that sits right at the heart of every single AI project. Do you need a simple generator, a predictable workflow, or a dynamic agent? Nailing this choice up front? Well, it's everything. Here's your playbook simplified. Always, and I mean always, start at step 1. Can a single, well-crafted LLM call solve the problem? If the answer is yes, you stop right there. You're done. If no, move to step 2. Can one of those 5 workflow patterns solve it? This is where most real-world use cases are going to live. And only if the task is truly open-ended, where you can't possibly predict the steps, and you have a really high degree of trust in the model's decision-making, only then should you even think about building a full agent. Start simple. And hey, if you do decide to build an agent, please listen to this very carefully. Anthropic says they spent more time optimizing their tools than their main prompts. The way you define your tools, what they call the Agent Computer Interface, or ACI, is the #1 reason agents fail. A vague description like the one you see on the left is just going to confuse the model. You need production-grade tools with crystal-clear descriptions, absolute file paths, and explicit parameters, just like you see on the right. And yeah, we have to talk about the money. Your choice of architecture has massive financial implications. A simple GenAI call might cost a fraction of a penny. A workflow multiplies that, sure, but a free looping agent, it can get stuck and rack up an absolutely insane bill. We've all heard the horror stories, right? Like the agent that burned through over $4,000 in a few hours because it got stuck in an error loop. This just perfectly illustrates why starting with the simplest architecture is also the smartest financial choice. So let's just burn this mental model into our brains for good. Layer 1, generative AI for creating content. Layer 2, AI agents for single dynamic tasks. And Layer 3, agentic AI systems for achieving end-to-end goals. And right in the middle, you've got those 5 powerful workflow patterns that are going to solve most of your real-world problems. The rule is simple. Start with the simplest architecture you can. Only add complexity when you can actually prove with data that it's making things better. So the next time someone asks you to build an AI agent, what's the very first question you're going to ask them?